in this graph, we've got some energy changes that are depicted. We need to remember that this is the start energy, or the energy of the reactants. That's the end energy, or the energy of the products. If I'm going in the forward direction, then that from the reactants up to the activated complex is going to be activation energy. If I'm going in the reverse reaction, then from this line all the way up to the activated complex will be the activation energy of the reverse reaction. This line over here brings down the activation energy, so it represents a catalyst being added. And if that happens, my activation energy for the forward reaction, much smaller, and so is the activation energy for the reverse reaction. Remember, a catalyst does not get involved in the reaction. All it does is it brings the activation energy down by changing the mechanism of that reaction. No matter which of the four reactions I am considering, be it the forward uncatalyzed, the forward catalyzed, the reverse uncatalyzed, the reverse catalyzed, my delta H number will stay the same. The forward reaction here is exothermic, so my delta H would be negative, and the reverse is endothermic, and so my delta H value would be positive. So now that we've unpacked this graph, we can now look at what were the questions. Delta H for the forward reaction is going to be represented by 3. The activation energy for the reverse uncatalyzed reaction will be 5. The activation energy for the forward uncatalyzed reaction is going to be 1. If a catalyst were introduced, the activation for the reverse reaction would be represented by 4, and the reverse reaction over here is an endothermic reaction. The following diagram illustrates a change of potential energy for the reaction. So again, we're taking a look at this concept of potential energy on the y-axis and reaction coordinate on the x-axis. We are told that for the forward reaction, 92 kilojoules of energy is released. We can see this is the shape of an exothermic graph. Why? Because the products have got less energy than the reactants, which means that energy has been lost to the environment. So I know that 92 kilojoules has been lost to the environment. What is the heat of the reaction, negative 92 kilojoules, per mole of XY3 formed? Here's the equation. And for every time that this reaction occurs, I actually make 2 moles of XY3. So I now need to take 92 and divide it by 2, and I land up with negative 46 kilojoules per mole. That is a higher order thinking question and quite unusual, but worth stretching your brain over. Determine the activation energy for the forward reaction in this graph. So if I'm looking at activation energy, it is the energy between the reactants and the activated complex. So from 40 to 60, I am going to put in 60 kilojoules. And determine the delta H for the reverse reaction. So now the reverse reaction in this case is a endothermic reaction, which means I'm going to have a positive value. So either I'm on A or I am on C. And the delta H is between 20 and 40, so I am going to subtract and I'm going to get positive 20 kilojoules. The next one, they now want me to determine the activation energy of the reverse reaction. Again, reverse reaction in this case is endothermic. Activation energy for reverse reaction is between 50 and 250, so it's going to be 200 kilojoules. Determine the delta H value for the forward reaction. Forward reaction is an exothermic reaction, so I'm going to land up with a negative answer, so it's either B or D. And I am going between 50 and 100, so it's going to be negative 50 kilojoules. Define the heat of the reaction. This is just a definition. It is the net change in chemical potential energy of a system. That is your definition of the heat of the reaction. Define an exothermic reaction. An exothermic reaction is going to convert into thermal energy, is what I end with. In other words, heat is given off in the end, and it comes from chemical energy and becomes heat energy. So A is my correct answer. What is the activated complex? It is a temporary transition state between the reactants and the products.